This video is on perpendicular bisectors. Just really quick, one example to do. The perpendicular bisector of a line AB is a line perpendicular to AB which passes through its midpoint. So it's a bit like a normal, it's a perpendicular line. By it being a perpendicular bisector, the bisector element of it means it goes through the midpoint. So that's something really important to remember. Just one example, we've got point A, negative 1, 2, and B, 3, 4. Find the equation of the perpendicular bisector. Remember, we need a gradient and a point on the line to get this equation. Now, on the perpendicular bisector, A and B at neither of those points will be on the line. If you look at the diagram above, say if A was here, B is here, the perpendicular bisector is directly in the middle. So the point on the line that we're going to substitute into our formula would be the midpoint. The first thing we need to find is the midpoint. That's always represented by a capital M. And the midpoint formula we did a few lessons ago. And so it's the x values added together divided by 2, and the y values added together divided by 2. Then our midpoint would be 1, 3. I'll just quickly put the equation for the midpoint at the side here, just in case anybody has forgotten what it is. Now we've got the midpoint, we need to find the gradient. Now to find the gradient, we've got A and B. We can just use those, so our m equals y2 minus y1 over x2 minus x1. Solve that and we would get 2 over 4, which is obviously the same as a half. You would be expected to simplify that to a half. Now we're finding the perpendicular bisector, which means we actually want the perpendicular gradient. So to do this, we've got to flip the fraction, which would end up with 2 over 1. Change the sign, the original gradient is positive, which means our perpendicular gradient is negative. So negative 2 over 1, which is just negative 2. Then we have our gradient and we have a point on the line to sub into our formula. Final equation would end up being y minus our y coordinate from the midpoint, which is 3, equals our gradient, negative 2, of our x minus our x coordinate, which was 1. And there we have our equation of the perpendicular bisector. And obviously from there you can rearrange that into different forms. So if you need to graph it or anything like that, you can very easily make that into y equals mx plus c, or just a y equals equation. You could just do y equals negative 2 x minus 1 plus 3. Just if you ever need to graph, you don't need to expand it to be able to graph an equation on your calculator or anything like that. We just have to make it to the form y equals. And that is perpendicular bisectors.